Hi, and welcome to Allen High School Pre-AP Chemistry, and welcome, of course, to my best chemistry students. Yay! All right, we're talking about some formula stoichiometry, and this was a review of what we did before. We are given formula units, and we are asked to determine how much it weighs in pounds. I'm not sure what that is. It's just a typo somewhere. So how much does a sample weigh in pounds? Now, I don't know of a conversion between formula units and pounds, but I can get from formula units to moles. And this is a count, so when we're dealing with counts to moles, we use Avogadro's number. Well, then I know how to get from moles to mass. Well, fortunately, this gives us the conversion we need for mass to pounds. Now, I don't know if you noticed, but I did skip numbers 18 and 19. If you need to see those, I'll show them to you in class. Sorry, I should have mentioned that at the beginning. Now, in a perfect world, we wouldn't deal with American units anymore, but it's not a perfect world, so you need to start writing letters to your congressmen and congresswomen so that maybe your children don't have to deal with this. All right, this gets pretty long, and so I do think the railroad way helps us with that. Okay, so I'm going to start with my given, 7.32 times 10 to the 24th formula units. That's a count, so if I want to get rid of a count and go to moles, you can do it if you use Count Avogadro's number. So I'm here on my little journey. Now I want to get rid of moles and go to mass. Mass to moles, use molar mass, which means that you have to recognize that mercury 2 chloride, if mercury is 2 plus, we'd need 2 chlorides, and you'd be able to determine from the periodic table that 1 mole of this weighs 271.5. Right? Mass to moles, use molar mass, and the molar mass you get from the periodic table. All right, so now I'm here in my journey, but I'm not done. I want to eliminate grams and I want pounds. You do not have to memorize this. Back in the day when I was first teaching at Allen, we made you memorize. We don't anymore. I want 1 pound and there's a 454 grams. Now, before you start your algebra, walk through and make sure that you set up your units to cancel. I'll get distracted and mess up my units. You want to be very careful. And fortunately, all of my units canceled, and I get 7.27 pounds of my mercury 2 chloride. Don't forget these units, and don't forget to pay attention to sig figs. All right. Let's move forward, and we're going to add another component to this. And this is atoms within. So what I'm talking about here is I had mercury chloride. How many chlorines within, or chlorides, better yet, within? If I have water, how many hydrogens within? So when we're talking about atoms within, we're talking about atoms within a formula unit or a molecule. Now, actually, you can do this step in 2 different places. We can do it here. Let me get you a little bit more complicated one. Let's say we have C6H12O6. What that formula tells me is that for every 1 molecule, so for every 1 molecule of C6H12O6, I am going to have available 6 carbons. So if I was going to combust it, for every 1 molecule, I have available 6 carbon atoms. So that's if you want to convert it this step. We can actually do it here instead. Okay? It depends on how you want to do it. We could do it at the mole to mole. So there's 6 moles of carbon for every 1 mole of C6H12O6. Right? Now, if I was talking about water, I would say that for every 1 molecule of C6H12O6, I have 12 hydrogen atoms. Now, I can do this conversion at the mole level because for every 1 mole of C6H12O6, I also have 12 moles of hydrogen atoms. So you can do these conversions at either step. All right? So question mark carbon atoms. How many carbon atoms are there? In 16 grams. So I want to map out my problem. I want to know atoms within. All right? And that means I first have to get, I'm going to do it 2 ways. First have to get to molecules. I can't go directly from grams to molecules. I've got to go through that heart of chemistry, and then I can go from grams. So we're going to start here, and we're going to have 1, 2, 3, we're going to have 3 steps in this problem. So I have 16 grams of C6H12O6. Now, I want to get to the heart of chemistry, so I want to eliminate grams and go to moles. For every 1 mole, should be able to count 6 times 12.01 plus 12.101 plus 6 times 16 gives you 180.1 grams. Now, I want to eliminate moles of C6H12O6, and I want molecules. Now, a molecule, remember, is a count. So if we're dealing with a count, we can use count Avogadro's number, 6.02 times 10 to the 23rd molecules. Now, one more step. I'm right here on my map. I want to get rid of molecules, and I want to go to carbon atoms. So carbon atoms. When we're talking about atoms within, we look at our subscripts. There's 6 carbon atoms per 1 molecule. All right, let me show you this the other way because some of you will like this better. And in this aspect, I'm not overly picky about this part. So let me show you another way to do this. We could go 16 grams of C6H12O6, right? And then I've got 1 mole of C6H12O6 for every 180.1 gram. Now, instead of going to molecules, I'm going to go to carbon. So for every 1 mole of my C6H12O6, I have 6 moles of carbon. Now I can eliminate moles of carbon and go to atoms of carbon. And atoms are a count. So once we have it down to, directly with atoms, 6.02 times 10 to the 23rd atoms for every 1 mole. So you see that those last 2 steps in this case can be flip-flopped there, and you can pick the way you want to do that. 3.21 times 10 to the 23rd atoms of carbon. Okay. Now I'm going to do just 1 more of these. We'll see how time flies or permits for this. I think I have time for just 1 more. I have aluminum. Well, let me do this aluminum sulfide, and then if there's time in class, I'll pick up the last example here. Aluminum is +3. Sulfite is -2. So this is aluminum sulfite. All right, I'm just going to show this the one method way. Those of you who like to do it at the mole level, you are welcome to do that. So I'm going to have 1, 2, 3 steps. You start with your given. So I have 4.55 times 10 to the 23rd atoms. Notice you have atoms of aluminum. And we're asked for mass of aluminum sulfite. So this is backwards of the other one. So I want to eliminate atoms of aluminum, and I want to get to my formula unit. And that subscript tells me that there's 2 atoms of aluminum for every 1 formula unit of aluminum sulfite. Now we can get rid of formula units and go to moles. Now remember, formula unit is something you count. So it's 6.02 times 10 to the 23rd formula units per 1 mole. I'm not there yet because it asked me for grams. Now, if you're a little bit lost, look at that map while I'm working these, and I think you'll get a better idea of what we're doing. 294.15 grams of aluminum sulfite. I got that by taking 2 times aluminum's molar mass plus 3 times sulfur plus 9 times oxygen. And that's per 1 mole. And if I got my algebra right, I have 111 grams of my aluminum sulfite. So that means if I want to synthesize aluminum sulfite and I have this many atoms of aluminum, I'll be able to make this many grams of aluminum sulfite. So that's effectively what we're saying here, what we mean. All right, I want to do one more. I just changed my mind because they each teach something different. So this says how many nitrogen atoms are equivalent to 45.8 grams. Now, ammonium is NH4 plus and nitride is N3 minus. So we need 3 positives to balance out that -3. I think you'll see why I wanted to do that in just a minute. So I have 45.8 grams, and I want to first get to the heart of chemistry. Mass to moles, use molar mass. We get our molar mass from the periodic table. Okay, sorry, I was thinking ammonium and did an M. NH4, 3N. Now I've got 3 plus 1 is 4 nitrogens plus 12 hydrogens. So if we added all that up, you'd get 68.12 grams. You may want to pause the video and double check and make sure you're able to get that molar mass. Now I'm going to go, if you look at your map, I can go from moles to formula units. So I want to eliminate moles. So grams have canceled. I want to eliminate moles and go to formula units. A formula unit is a count, so I get to use Avogadro's number, 6.02 times 10 to the 23rd. Now the question said, how many atoms are there within? Don't use Avogadro's number when you're doing atoms within. Atoms within, we use subscripts. And the reason I did this is for every 1 formula unit, you might get mixed up. You might not pay attention to every nitrogen. I get 3 nitrogens from the ammonium, but then I get a nitrogen from the nitride. So I actually have 4 atoms of nitrogen. And if you did that math, you'd get 1.62 times 10 to the 24th atoms of nitrogen. All right, in the next video, we're going to change gears a little bit and look at percent composition. I think you'll really like these. These are very straightforward. We don't usually have trouble with those. So until then, guess who this is? Signing off. Love ya.